Good day everyone, I am Zainika B. Llamas and today I am going to discuss what valence electrons is, how to identify it, and its importance or applications in our daily life. Before we proceed, let's go over to the objectives of this lesson. So, by the end of this lesson, students will be able to explain the importance of valence electrons in chemical bonding, identify the number of valence electrons in a given atom, and draw electron dot structures to represent valence electrons and predict chemical bonding. So ano nga ba ang valence electrons? Ang valence electrons are the electrons located in the outermost shell or energy level of an atom. Ibig sabihin, ang valence electrons ay matatagpuan sa pinakalabas na layer ng isang atom. Sila ang mga elektron na kasama sa pagbuo ng mga chemical bond sa pagitan ng mga atom. These electrons are critical in determining the chemical properties of an atom and how it interacts with other atoms to form chemical bonds. Understanding valence electrons is fundamental to grasping chemical bonding, molecular structure, and the periodic behavior of elements. This report provides a detailed overview of valence electrons, their significance, and applications in various fields. So ito na nga, valence electrons are those in the highest energy level or the outermost shell. So makikita nyo po sa larawan, ang outermost shell ay nasa pinakalabas. Of course, it's the outermost. Then mo po makikita ang valence electrons, those red circles around it. So may example po tayo is the oxygen. Ang oxygen, it has 6 valence electrons. Makikita naman po doon sa figure. So dito po, may sample akong ginawa on how to identify the valence electrons using the atomic number. So yun po, ang ginamit ko is fluorine. Ang atomic number ng fluorine is 9. So para mahanap yun, you just need to draw the core or yung inner shell po, yung first shell, using, dapat po may symbol ng fluorine sa gitna, of course. Tapos ang core shell, kaya lang po mag-occupy ng 2 electrons. And the second shell po, kaya po mag-occupy na hanggang 8 electrons. So yun nga po, dahil po may 9 electrons ang fluorine, yung 2 nasa core electrons, and yung 7 is nasa outermost shell. Meaning, ang valence electrons ng fluorine is 7. And the core electrons is 2. So dito naman po, ginamit ko yung atomic number ng aluminum which is 13. So uulitin lang po yung procedure. Yan, nahuhusan pa ng tinta yung ballpen. So yan na nga po. Sabi ko nga, ang first shell can occupy 2 electrons and the second shell is 8 electrons. Ayan po, may third shell na po siya kasi nga po 13 electrons po ang nasa aluminum. So, ang meaning, ang valence electrons po ng aluminum is 3 kasi yun po yung nasa outermost or pinakalabas na shell. And then the first and second shell, which is the core electrons, is 10. Yung nasa first and second shell. Yun na po yung core electrons with a total of 13 electrons. So, ito naman po, pwede natin ma-identify ang valence electrons ng isang element using electron configuration. So, the arrangement of atom is described by its electron configuration. So, dito nga po, nag-illustrate ako ng example on how to find the electron configuration of nitrogen. So, anyway po, ang 1s2, 2s2, and 2p4 is the electron configuration or the arrangement of nitrogen. So, iyon pong 1 is ang tawag po dyan is shell number. And the S po is subshell type. Tapos po, yung parang exponent is superscript. It's indicating the number of electrons. So, dyan po, makikita na ang valence electrons ng nitrogen is 5. Kasi po, yun po yung nasa outermost shell. And the core electron is 2. So, ito nga po, another example is oxygen, which is 1s2, 2s2, 2 and 2p4. So anyway, the S subshell can hold 2 electrons and the P subshell can hold 6, and may D subshell po yan, it can hold 10 electrons. So dito nga po sa oxygen, dahil ang oxygen has the 6 valence electrons, which is the 2s2 and 2p4, i-add lang po yung 2 and 4, which is 6 nga po. And the core electrons of oxygen is 2. So, uulitin ko nga po, ang outermost shell, dun po matatagpuan ang valence electrons, or in the second energy level. And here naman po, we can also determine valence electrons from the periodic table. So, paano nga ba yun? We can find it on the group numbers. The group number in periodic table often indicates the number of valence electrons for main group elements. And here in transition metals, we can have variable numbers of valence electrons due to the involvement of the electrons in bonding. You typically need to look at the element's electron configuration to determine valence electrons. So here po, I illustrate ang table para ma-identify kung paano nga po mahanap ang valence electrons using the periodic table. So, find the element's vertical column or group on the periodic table. And then, match the group number. It is for the main group elements. So, ang valence electrons po is equal to the group number. Example po, group 1 has 1, which is the hydrogen, lithium, sodium, and potassium. Then, ang group 2 po has 2 valence electrons. Kumbaga, equal lang sila. So, dito po sa, nakikita nyo po sa video, nag-skip na po tayo sa transition metals and we proceed to the group 13, which is, has a valence electrons of 3. So, paano nga ba naging 3 ang valence electrons ng group 13? So, you just have to subtract 10 from the group number or simply use the second digit of the group number. Example, sa group 13, may 3 electrons. And group 14 has 4 electrons. And group 18 has 8 electrons. So, may exception po dito, which is the helium. Kasi ang helium ay nasa group 18, pero ang valence electrons niya lang po ay 2. So, ito nga pong nasa video na ginagawa ko. The boron, aluminum, and gallium has 3 electrons, which is yung nasa group number nga po nila. Kung makikita nyo nga po doon sa helium, nilagyan ko po siya ng exponent na 2. Kasi nga po, ang helium ay may 2 electrons lamang kahit na nasa group 18 ito. Next nga po, itong Lewis dot structures. It represents valence electrons as dots around the element symbol. These structures are used to visualize bonding between atoms. So as you can see nga po on the figure, it's a symbol of beryllium. It has 2 dots, meaning it has 2 valence electrons. So next nga po is the formation of chemical bonds. When atoms form bonds with other atoms, it is known as chemical bonding. Atoms will form chemical bonds with each other in order to fill their electron shells and gain stability. May 2 main types of chemical bonds po, which is ionic and covalent bonds. Ionic bonds form through the transfer of valence electrons from one atom to another, creating ions. So dito nga po is the ionic bond example. So, sodium has 1 valence electrons and chlorine has 7. These atoms can form an ionic bond in which chlorine steals sodium single valence electron, creating stability for both atoms. So, sodium can become stable by losing its single valence electrons and dropping down the previous energy shell, whereas chlorine can become stable by gaining 1 or more electrons and filling its outermost shell. And dito nga po is the covalent bond. It takes place when rather than taking or giving electrons, atoms share their electrons in order to fill the energy shell. And here's the example of covalent bond. valence electrons and therefore needs one more in order to fill its octet. Both atoms will share one electron, thereby completing their electron shells. So in the absence of any other element, chlorine atoms can bond with the other chlorine atoms. And here are the properties influenced by valence electrons. First is reactivity. Elements with fewer or more valence electrons than a full shell are more reactive. Second is the bond strength. The number of shared electrons affects the strength of covalent bond. And here are the application and relevance of valence electrons. First is predicting chemical reaction. Understanding valence electrons helps predict how elements will react with each other. For example, alkali metals in group 1, it is readily react with halogens in group 17 to form salts. And second is designing new materials. Valence electrons is crucial in materials science for designing materials with specific properties such as conductivity and strength. For example is semiconductors like silicon. It has 4 valence electrons, making them ideal for electronic devices. And the third is pharmaceutical development. Valence electrons play a key role in how drugs interact with biological molecules. Example is drugs bind to target molecules through interactions involving valence electrons such as hydrogen bonding and van der Waals forces. And last is environmental science. Valence electrons are important in understanding the behavior of pollutants and their interactions with environmental components. For example, the reactivity of pollutants like ozone is determined by its valence electrons configuration. And here are the summary and key points. First is, valence electrons are the electrons in the outermost shell of an atom and determine its chemical properties. The number of valence electrons can often be determined from the group number in the periodic table. Third is, atoms tend to gain, lose, or share valence electrons to achieve a stable electron configuration, often following the octet rule. Next, Lewis dot structures are used to visualize valence electrons and bonding. Valence electrons are crucial in forming ionic, covalent, and metallic bonds. Last, understanding valence electrons is essential in predicting chemical reactions, designing new materials, developing pharmaceuticals, and addressing environmental issues. That's it for today's video on valence electrons. I hope you learned something. Always remember, valence electrons are the key to the chemical bonding, and understanding them is essential for understanding chemistry. Thank you for watching. Bye!